Which causes instability challenges in the electrical grid? Select the three best answers. One of the choices is grid-tied inverters out of phase with the grid's AC power. One choice is long periods of still air in regions relying on wind power production. Long periods of sunless days in regions relying on photovoltaic power production. Photovoltaics charging electric car batteries. Photovoltaic panels that face east or west. Standalone battery bank photovoltaic arrays. Now, the answers are these first three, kind of. For those of you guys who are not comfortable with positive ambiguity, this is going to be a tough 40 minutes of competence. But grid-tied inverters out of phase with the grid's AC power, long periods of still air when there's wind power, long periods of sunless days when there's photovoltaic power production. Photovoltaics charging electric car batteries, that's no problem at all. Actually, that's the future. Photovoltaic panels that face the east or west, that's not optimal. South is generally better, but are always better. But sometimes you got to face east or west based on which way your roof goes or where the trees are that might shade something. On standalone battery bank photovoltaic arrays, they're probably in most cases not as good of an idea as a grid-tied system, but there's nothing about them that causes instability. So this is my house. Many of you guys know this now. And these trees that are all around it, especially on this side, and the weird shape of the roof that really has nothing really facing south is this way. And so it's like a chimney and it's a small part of a hipped roof. And so last month, I every so often I'll ask, well, only once before. So this is the second time I'll ask the photovoltaic company local to me and say, well, go ahead and see what see if we can do it on my house. Because for obvious reasons, all kinds of obvious reasons, I want photovoltaics. I want to produce my own power. And this is what they came up with. So these three panels facing south, but these trees kind of get in the way a lot of the time. These 5 panels facing west, which is again less than ideal, but not the end of the world. You can still make something out of it. But in reality, the benefit of this is, so this is going to, because it's a relatively small system. It's a 3 kilowatt, and it's about $3.50 installed per kilowatt. A little bit more than that actually. And the local average around here is about $2.50 per kilowatt, a little bit more than that, but I'm sorry, per watt. So it's expensive. And part of the reason it's expensive is I just don't have a lot of good sun and my climate isn't super sunny. And they'd have to go up there on the roofs and 2 different roofs and run wires from 2 different roofs and still have a lot of the other equipment. And that's the equipment we're going to talk about now. We're going to talk about the inverter, kind of what's an inverter. Now, again, if I had my druthers, if things were going really well, maybe I'd have, instead of 8 panels, I'd have something like, I don't know, 25 panels. If everything happened to line up right. And instead of 3 kilowatt, instead of a 3 kilowatt system, I might have a 8 or 9 kilowatt system. That would be, something that in the East Coast, if you had good solar access, might be doable and might be ideal. So what am I doing? Well, if I do it, I have to get an inverter. And so the whole purpose of an inverter is to allow you to take the DC current from a photovoltaic panel and transform it into the AC current of the grid. And we've talked a lot about DC and AC and photovoltaics in the last month or so, 2 months in Amber Book 40 Minutes of Competence. Why? Because people keep asking questions. And I try to kind of respond to the community. And the way that it typically works for folks in most states is you have what are called net metering laws. So this is your electrical meter. It runs forward when you're drawing electricity from the grid. But when your photovoltaic array is supplying electricity to the grid, it runs backward. So at the end of the year, you want to hopefully net out to zero. And all of these states have some form of net metering policies, although some are voluntary. And so what I'm kind of waiting for is, okay, I could put it on my roof, but maybe my roof isn't so ideal. you know, and even the flat part of my roof is maybe not so ideal because it faces west. So what I'm kind of waiting for is, um, I don't know how long I'm going to wait, but apparently it's pending here in Virginia. I actually, right before this, sent an email out to see what the status of the legislation is, but where you can have, oh, what do they call it? I'm blanking on the phrase. It's basically where I can purchase some photovoltaic panels here or some other place, and then use that to cancel out my meter remotely. So it doesn't have, I don't have to produce it on my property. I can produce it on someone else's property and use that to work backward, and then I can get my numbers probably closer down to, you know, $2.25 or $2.10 per watt, and then and so we can kind of, you know, maybe it'll, I'm not sure how, I think it has to be, it's going to have to be produced in Virginia, but wouldn't it be amazing? I mean, carbon is carbon. I'd love to, I'd love to produce more energy for the same, more power for the same dollar, by, you know, producing electricity in Saudi Arabia or Morocco or or Arizona. So there's no reason, you know, from a kind of, from a carbon point of view, which is my passion, there's no reason that it has to be produced locally, even though, you know, it probably feels pretty good to have it on your building, but it does not have to be on your building. We probably have to loosen up those thoughts in general. And one of the big problems with one of the reasons that the one of the challenges for this kind of transformation to the electrical grid that we're all waiting for and excited about is that the type of engineers who went into, I don't want to paint them with too broad a brush, but if you're an engineer, if you're an electrical engineer, and you could have gone into, you know, computer design, you know, electronics, or you could have gone into rocketry, or you can go into being the people who are in powertronics, which kind of deal with the electrical grid. You can imagine over the years the type of engineers that chose to go in the utility direction instead of in the startup direction or NASA direction or Air Force direction or whatever, were typically people who were slow to change. They were not the most innovative group of people as a whole. And they went because they wanted something where they wouldn't have crazy days and long ups, you know, crazy ups and downs, and you know, fear of getting laid off. And those are the kind of those are the kind of people that typically went into that went into the technical side of providing us with our electricity. And so now those people are having to adapt to the fact that they are the new superstars, and they need to be really innovative and really fast moving. And that is not what those electricity utilities were set up with. Most of them, as you guys know, if you remember your history, have what are called natural monopolies. It didn't make sense to have a different power grid for every new company that came on. In other words, if your small town had 5 electrical companies with 5 different poles and 5 different sets of wires, that was not an efficient way to provide electricity for one town. It was everyone's rates would be much lower if, number one, there was just one pole going down the street instead of 5, not to mention the safety and maintenance, tree cutting, excuse me, safety and maintenance and tree cutting, and you know, unsightliness of having all those poles going down the street. But also, the second thing that would need to happen to keep the rates down was they would have to be regulated as monopolies, because if the state is essentially, and you know, the government is essentially, maybe the local government is going to choose who's going to deliver your power, who's going to be the winner, who's going to get to, what for-profit company is going to get to send power. In my case, it's a not-for-profit company, but in most cases, it's a for-profit company who's going to get to send power down your street. Then there's got to be some kind of a regulation where they're going to make sure that there's not the evil side of a monopoly. So the regulators determine how much your power company can charge you. And they look, you know, every, I don't know, quarter or something, they'll look at what the power company is paying for fuel, how much they're charging customers. And if the power company wants to do a rate hike, they have to apply to the, you know, the state commission. And the state commission will look at the numbers and say, yes, you may charge a little bit more. It's a very safe investment. It's not a very high risk investment, but of course, it's also not a very high reward investment either. I'm talking about investing in utilities. That's the whole kind of idea. They're steady because they're monopolies. But To understand how this question works and what the kind of role of an inverter, and we're going to have to talk one more time about AC current and DC current. So in AC current, which is how the grid brings electricity to your building, you have a power plant. And it's producing electricity, and it's sending that electricity down the wires to a transformer. Outside of your building. And then the transformer is stepping down the voltage, and then it's going inside your building where it's going to go to the electrical outlet. And from there, it's going to go to your device, your light bulb. It's going to light up your light bulb. And then it's going to go back on the neutral wire to your outlet. And from your outlet, it's going to go back to your transformer. And from your transformer, it's going to go into the ground. Now, the neutral wire is not the ground wire. The ground wire is different, but the neutral wire is grounded. And so the ground's going to become a reservoir of electrons. And so what's going to happen is the electrons are going to go down from the power plant to the transformer to the electrical receptacle to the light, back to the electrical receptacle, back to the transformer, into the ground. But it's alternating current, 60 times per second. It's going to go back the other way and back to the power plant. So back and forth, back and forth, back and forth. Now, the way that direct current works in the case of photovoltaics is you have photovoltaics. They're going to produce electrical power that only is going to go one direction. Now, if there's no battery, and we can talk about batteries in a second, but if there's, this is the sun. If there's no battery, then it's going to go into this inverter. And what the inverter is going to do, the inverter looks like it's about the size of a microwave on your wall, but not nearly as deep as it's about as deep as your TV, maybe a little deeper. And what the inverter is going to do is it's going to tie into the grid. It's going to tie into the telephone poles, and then and actually first it's going to go through your meter and run everything backward. And then if your building needs power, if you need your light to run, let's see. If you need your light to run, it's just going to draw power the same way it does in my non-photovoltaic house. It's going to pull it directly from the grid, and it's going to light everything up. And so basically you're using the grid as your battery. It's not literally storing it, but you're sending it when you're producing more power than you're using, or even if you're not, you just send it all to the power company. You just send it all to the power company, and the power company runs your meter backward. And that may seem like a less than ideal way to do it, but it actually is a pretty nice way to do it. Having batteries are expensive. They are really nasty in a fire. They wear out. They're not great for the environment themselves. So if you have access to the grid, if you're not in some remote New Mexico, middle of the mountains kind of place, if you have access to the electrical grid, you generally are better off tying into the grid. Now, we also have a situation though where all batteries use DC current. So if you have an electric car, if you have a electric car in your driveway or in your garage, we can divert some of the some of the power, we can divert it towards charging up the battery in your car. And so, of course, there's electronics that deals with, decides whether to send it to the grid or to the car. But we can, and then we can use the car as Tesla's kind of theory is we're going to use the car as a source of power for the building or for the house, typically, in case the power goes out. Because the interesting thing about this system is without the battery in the car, without some kind of a battery system, when the power goes out, you can't produce electricity anymore because there's no way to store it. And we can't store electricity if we don't have batteries. So the inverter shuts everything off. So a lot of people think if they have a photovoltaic system, they'll be set if the power goes out. But if the power goes out, they still don't, unless they have batteries, which many systems do, or unless they have an electric car, which many people do. 9% last year of new vehicles were electric cars. But unless they have that, then there's no opportunity to still power your house or your building. So knowing this, you can understand how if 60 times per second the electrons are moving back and forth, so they're moving this way and 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 this way, and then they're moving back the other way. So they're moving this way and this way and that way and that way and that way and that way. And they're doing that 60 times per second. And so what the inverter is trying to do here is it needs to match that. And so it needs to work exactly at the same time. So when the electrons are zigging, the inverter needs to zig. And when the electrons are zagging, the inverter needs to zag. And so if the inverter was out of sync, was out of phase, if it was zigging when the rest of the electrons were zagging, that could, in theory, cause some disruption to the power grid. And in fact, I must admit, there were some years ago, because I had heard that was a thing, where I explained that to my Virginia Tech students. I would say, this is a problem, but it's not a common problem. And I just kind of went on with it. Well, it turns out it's not a problem at all. It was rumored, it is widely believed to be a problem, and it is theoretically a problem, but it's never happened. It's just not a thing. The electronics in the inverter don't work unless they're synced up with the alternating current. They're all made to just not work. So it's not like there's these rogue inverters that are singing out of tune or singing too fast or too slow, I guess would be a better way to think of it. That's not a thing. And so, California, that you guys in California, you've got California now has 1 million photovoltaic systems on houses. And it just never happens. It never, ever happens. So why did I say that one of the correct answers is grid-tied inverters out of phase with the grid's AC power? Well, in theory, that would cause instability, but it's not a thing. So how can that be? Well, I don't know that NCARB knows it's not a thing. In fact, I suspect NCARB does not know that. And when I took the exams, I think probably on each exam division, I probably found 1 or 2 questions that I knew to be wrong. And the reason I know them to be wrong is because I, do this full time. I know a lot about this stuff. And the people who are making these questions are volunteers who, in many cases, don't know as much about some of this stuff as I do. And so I find I found mistakes on it all the time. And so you can expect to find some things. I mean, especially out of the 600 questions, you can expect to find some bad questions. Now, typically when people think they found a bad question, they really just don't know as much as they think. It's actually usually, in my experience, I think typically, unless you happen to know a lot about the topic, typically you didn't understand the question, you misread it, or you misunderstood, or you don't know as much. So most of the time you don't know as much as NCARB. But there are some times where you know more than NCARB about a given topic, and you may see something like this, and you're just going to have to do your best to recognize that you need about 2/3 of the questions right to get a pass. So, okay, if any one question, and you have, most of these exams have between 65 and 100 questions. So any one question that's bad, it's probably not that big a deal, and you'll probably get it right anyway. You'll be able to figure out either what they were thinking, or you just have to take a guess whether or not you think NCARB knows what the real answer is. Now, long periods of still air regions relying on wind power production, that is a problem. And that's one of the challenges for the upcoming grid that we're all going to be enjoying soon, hopefully. is that if you have a lot of wind power and there's no wind for a couple of weeks, that can be a real big problem. Or likewise, if you have a lot of photovoltaic power and there's no sun for 3 weeks, and you have to power Tokyo, you're in a bit of a pickle if you want to do it without photovoltaic. I mean, without fossil fuels. Now, what do the smart people say we should do to deal with those two? Long periods of still air with wind, or long periods of sunless days with no sun, with a lot of photovoltaic. What are we going to do? What are we going to do if we want to provide power for the world, but we don't want to burn fossil fuels? Go ahead and put it on the chat. Yeah, you got it right. It's nuclear. It's nuclear. So nuclear is this really promising old technology now that everyone's been moving away from. Germany, after the Fukushima plant disaster in Japan, Japan went away from nuclear, Germany went away from nuclear, and this is a huge mistake because they all had to reopen their coal plants. The fact that environmentalists have run away from nuclear, to me, is just just the most maddening thing. But nuclear is, of course, not a fossil fuel, and it doesn't contribute a meaningful amount of carbon to the air. All right, photovoltaics charging electric car batteries. Well, there's nothing inherently unstable about that. Photovoltaic panels facing east or west, and they're just a little bit less efficient, but nothing completely unstable about that. Standalone battery bank photovoltaic arrays, those are the kinds that work off grid. Nothing wrong with that either. So it's those first three that are the correct answers. So yeah, we generally put wind where it's windy. This is not a surprise, but every time you double the wind, so it's it's always like on an ocean or on top of a mountain ridge. Every time and they're often really big turbines. Every time you double the wind speed, you get 8 times more power output. So if you can put it where it's twice as windy, you can get 8 times the power output. And likewise, every time you double the diameter of the rotors, you get 4 times as much power output. So the future is not wind turbines on every building. The future for wind is really big wind turbines, really, really windy places, and preferably ones where there happens to be a giant electrical pole nearby, so they can tap into the grid. And here's again what another type of inverter would look like. So this is what I'm talking about, an inverter. At least for a house, this is what it looks like. It can be bigger, obviously, with bigger buildings. If you're interested in signing up for Amber Book, we have a coupon code today. It's just for the first 5 people, and it expires tonight. But it's inverter. So if you want to go to Amber Book and sign up for it, it's $170 off per month for all the months you use the course. For next week, we have a long question, and I'm going to go ahead and read it because I think it's worth thinking about and kind of marinating on for the week. An architect designs a chicken processing plant in Arkansas, where else, for a major multinational agribusiness corporation through the traditional project delivery method. After bidding and at the beginning of construction, several authorities having jurisdiction, AHJs, review the drawings. The building and zoning AHJ determines that though the building roof surface is under the maximum height limit set forth by the building and zoning code, the top of the roof parapet exceeds the maximum height allowed, and therefore the building, if constructed as drawn, will be in violation of both the zoning and building code. Further, an Occupational Safety and Health Administration, OSHA, official reviews the drawings and finds that the counter for workers to process meat as drawn fails to meet OSHA worker safety and ergonomics guidelines because some of the chickens coming down the line will be out of reach for the workers who will process them. The workstation counters, therefore, will require cutout notches like we see in these drawings for each of the hundreds of workers on the production line per the diagram. The cutouts are clearly spelled out in an OSHA poultry processing best practices publication. Which of the following statements best describes the architect's responsibility for redesigning to meet these requirements? Now, don't put your answer in the chat, please. The first choice is because the CD set has been completed, the project meets the standard of care threshold, and the project has gone to bid. The architect is not responsible for redesigning to meet either the height or the counter, either the building height or the counter regulation. Should the owner desire a redesign to address that should be to address the building code issue and worker safety issue, the owner will need to pay the architect for each redesign as an additional service. Second choice is the architect must redesign to meet the building and zoning code height requirements for free, because that's part of her obligations under the B101 owner architect agreement. But the architect should charge the owner an additional service fee for the worker safety regulation counter design. Or the architect should, for free, redesign to meet both the building code height requirement and the OSHA worker safety counter ergonomics requirement. All right. The other big news is that you guys had mentioned in our 100th episode, which was, I don't know, about a month ago, you guys had mentioned that you wanted us to celebrate by hosting a party at the AIA convention in Chicago. So we said, sure. I just said yes, because that's what we do. We just say yes when we can, which is almost always, we can almost always say yes. And actually, I was thinking it would be nice to start this with music. So start these things with music. So if any of you guys would attend these regularly and have a DJ background or have a band and want to play your music, I think we'd be game. So reach out to us at firms@amber-book.com and we'll make you our DJ. Maybe not permanently, but we'll try it out a few times, and maybe we'll have like some rotating DJs for that first 5 minutes. There's something kind of lonely about just everyone being on, but no one being able to talk. And I've tried it making it so people can talk, but no one really talks. And instead, one person unmutes themselves while they're doing the dishes. And so that's not a good look. So anyhow, but we're going to have a party and we want you to come, and we want you to come. We're inviting our firms that are in Chicago. We're inviting our firms that are our firm kind of point people that are across the country. We're inviting people who have said nice things about us. We keep a tally on social media. We keep track of when you guys say nice things about us. So we want to invite you. We're inviting you guys because you attend 40 Minutes of Competence, and we're inviting anyone who is in Chicago or will be at the conference. We are thrilled to host you, at least until we fill up. The venue we've secured, I think it has a limit. I can't remember what the limit is, but that's our limit for it's open to the first, X number of people. And so it's at this place, Fat Poor Tapworks. And you can, Tyler, I think right now is putting in the chat the RSVP link. So you can click on that link and you can join us. It's $5, but we give the $5 to charity. We're giving it to the the International Rescue Committee, so that to help the refugees that are around the world. But if you would go to that, if you want to come with us, it's an open bar. It's an open bar, and come join us. All right. I'm now going to open it up to questions.
Michael.
Hey, Megami.
I just wanted to make sure I understand what you explained about photovoltaics going. So if you can go to your first. Yes. So photovoltaics sends the power to inverter, which converts and sends it back to the meter, and then it goes to the grid. And then if I need power in my house, then I get power back from the grid, right?
Exactly.
Is that what? Okay.
Exactly. You got it. Unless there's a battery pack somewhere on the premises or in a car that's plugged in, that's the plan.
Okay. So if there is a battery, until my battery is fully charged, it will go to the battery and then it will go to the grid.
No, I can't say that for sure. Okay. I think it's smarter than that. So if, for instance, I think hopefully we're going to get to, I'm not sure where we're at right now, but we're going to get to a point where it knows whether you're, it knows how full your car is, but it may also know that it's the hottest day of the year and the power grid really needs the power. And so we may get to a point where it's smart enough where it's like, well, she hardly ever drives her car. But man, the power grid's going to shut down soon if we don't give it some more juice. So I'm not sure where it's going to go. My guess is right now, yes, you're right. It would power up your car till it's full, and then it would send it to everywhere else. Now, what's interesting about this actually is that let me pick a new color. Is that your computer, all of your electronics and anything that's battery operated, and many of your motors as well. So your electric shaver and your computer um, uh, and maybe even your elevator, they run on DC power. So when you see that plug, that cord that's plugged into the electrical receptacle, and then it has like looks like a python that swallowed a pig, and then it goes to power your DC computer, and sometimes this thing is at the is a big honking, like in Apple products, it's a big thing at the electrical outlet itself. And there are advantages. I'm fascinated by the whole design of that, because when when it's like I have it drawn, you always have to like bring a chair over to support this thing midstream. It's really annoying. But if you if you put it as the thing that plugs into the wall, and it's a big brick that plugs into the wall, it often doesn't fit, because where just the nature of the geometry of the power strip or whatever. So but anyhow, what this device here is, and you don't have to know this for the exam, but this device is a rectifier. It's also a transformer, and most people just call it a transformer, but it's a transformer rectifier. The transformer steps down the voltage, because we don't want to run electronics on 120 volts. It wouldn't work. Electronics don't work on such high voltage. But also electronics work on DC, and so do batteries. And so the rectifier I think it's IFIER. It may be A in there, but I think it's I. Anyhow, the rectifier turns the AC current back to DC current. So you see the irony where we're creating AC current, and we're going through kind of great lengths to transform it into I'm sorry, we originally are actually creating it with DC current at the power plant. Then we're turning it to AC current and sending it around the country. And then we're at a lot of our electronics, our TVs and so forth, we're turning it back into DC current in the end anyway. So, and same with our battery powered cars. So things are going to get interesting. If, I mean, there's just, and there's just so much room for improvement. And there's so much belief now that there's a lot of money to be made if we can get this stuff right. But there's not a lot of time. But I feel like there's the will. For the first time in my career, I feel like there's the will to do it right. So we'll see what happens. And the thing is, it's a competitiveness issue anyway, which is not, I know this is not what you asked, Makavi, but it's a competitiveness issue anyway. If the US is producing 10% of its power with renewables, and Germany is producing, let's say theoretically 100% of its power with renewables, then Germany doesn't have to pay for fuel. They paid a lot of money to get the photovoltaics and the wind turbines and such, but they don't have to pay a lot of money for the wind or the sun. That's pretty much free. So for you to run your steel plant in Virginia, you have to, your plant is indirectly paying for the fuel, paying for the coal that is used to make the electricity that is running your steel plant. But if you're competing in steel in a global market against a steel plant in Germany, and they don't have to pay for their fuel because it's free, their electrical bill, a steel plant here may easily have an electrical bill of $1 million a month. And a steel plant over there may easily have, once they go all green in this theoretical example, may have, you'd be using the same amount of electricity, but may have, I don't know, 1/10 that power cost. So their steel can undercut our steel. And so it's actually a competitiveness issue as well. There's so many reasons to do this. There's so many reasons to do this. But the difficult part is when you saw at the beginning, it's like inertia. I'm like, I don't know. I'll try again, see if I can get it on my house. Oh, it's going to look ugly, and I just don't have good sun. Maybe I'll wait till the laws change, and then I can buy a share basically of electrical power from a commune and use that for remote net metering to send my meter going backward and so forth. But you got the right idea.
Yes, thank you. I have just one more follow-up question. So only external thing that we are using here is inverter, right? Everything else is already there in our electric grid system, other than
the photovoltaic. No, I mean, I think there's probably some other things too.
Okay.
my guess is there's a few other things. I've seen some diagrams with another piece of equipment. I forgot what it's called, like a power regulator or something like that. My guess is there's some other things too, but I think most of those are the size of your fist. You know, they're like a little thing. They're like a little thing that you might not even see. The inverter is certainly, of the ones I'm aware of, besides the photovoltaic panels, it's the only one that's architectural in scale, even though it's not, you know, it's not huge, but it's the only one that, you know, that you would actually probably put on a drawing that wasn't a diagram.
Got it. Thank you so much.
All right, who's next?
Hi, Michael.
Hi, Rupa.
This is Rupa. Hey, this is not an ARE related question. It's more architecture. Can I still go ahead and ask you?
Please, my lord, please.
Okay. Okay. So a couple weeks ago, I am in Dallas, Texas. A couple weeks ago,
Mhm.
we had a lot of lightning and thunderstorm, and
Mhm.
the lightning struck on one of the houses in my neighborhood, and it burned down.
Oh, well.
And fortunately, the residents were saved. But now we are all thinking about the lightning rod protector, and I was wondering if you know or have any experience with that, or what are your thoughts on it?
It
Have
is
you seen it
funny.
work?
It is funny you mentioned that. I actually saw the coolest. Um, let me stop sharing for a second, and then I'm going to share again.
Mm-hmm.
So a couple of days ago, I took the students on a field trip to the chiller plant here on
Mm-hmm.
campus, and they have just the most prominent lightning protection. And the reason I'm going to show you photos of it. That's why I took this off for a second. The reason they have such prominent lightning protection is, number one, the let's see, here it is. Let's see. Number one, they're the biggest. This particular building happens to be by far the biggest. I'll share it now. I'll share it again. Happens to be the biggest by far around in this field. And in fact, we were out there for our field trip, and you could see this storm, this wicked storm just coming. It was one of the fastest moving storms I've ever seen. And it was
Mm-hmm.
perfectly fine 1 minute, and literally 30 seconds later, it was just, you know, howling wind, and you know, the students were cowering like cowards to not get rain on them. Let's see. All right, so you see it here, here,
Mm-hmm.
here, and let's see. Oh, you can see it all along these. This is the cooling tower impeller
Yeah.
fans, and you see where the
Mhm.
tallest thing around. You see all those fields around us, so there's not even a tree around. And so, and then yeah, you can see this system. It's right here. So the system of lightning rods, and actually this is very ARE related. There is a whole lot of
Mhm.
ARE on this topic, but this is system of you see this cable here. It kind of goes like this, and then it goes down and
Mhm.
hooks into the pipe. And so what's happening is every, I don't know, 4 or 5 feet all around that roof, there are little lightning rods, and sometimes big lightning rods that are intended to make sure that if lightning hits this particular system, it doesn't hurt the equipment. The equipment down below, the chillers that are down below. Let's see if I have pictures of them.
Mhm.
Here you see the lightning rod, you know, the
Mhm.
cables, and again you see the lightning, some of the lightning rods. Here's the cable again. Here's, you can see there's nothing around, and again more lightning rods, these little black things sticking up, and there you
Mhm.
go. Well, I took a picture of a camera for another 40 minutes of confidence. I swear I could do these every day. Um, but the reason is because there's, you know, there's tens of millions of dollars of chillers downstairs, and it's all being connected by water pipes. So if a lightning did hit it, it would do tens of millions of dollars in damage. So it's more than justifiable to put this, you know, I don't know, couple $10,000 system or whatever of just, it's basically, it's really dumb. It seems like it's complicated, but it's not. It's just giving the electricity a better path that doesn't happen to go through the whatever it is you're trying to avoid it going through. So typically you'll
Mhm.
have just a piece of metal that's a foot or two taller than anything else around it. You'll have a network of those if you have something really precious like these tens, $20 million chillers. And then
Mhm.
you take that, you take that power with a cable and you just connect it to some plumbing pipe that's not connected to the expensive equipment, or some railing that is eventually connected to some steel that's connected to the ground. So you just want to make it so it can go to the ground. But lightning hit my house. I wasn't home, but lightning hit my house, and my wife and my son said they heard a crackling moving through the wall. Like over the course of 5 seconds after the lightning hit the house, they could hear it moving through the wall. And in fact, we had to bring an electrician in afterward to make sure that we, didn't melt something that later is going to short. So yeah, as far as I know, this kind of system is effective. I don't know if it's worth it for a house, but maybe it is. Maybe it is.
Yeah, I guess so, because when I went and looked at the house, it's pretty much gone, and insurance apparently doesn't pay for everything. They will ask you for receipt for each and every small item in your
Oh
house
my
if you want to
gosh.
get paid, which is
Yes.
not possible. So
No, of course. So
I don't know how they are going to recover, but
I,
it's just very saddening to see that.
I have heard of people doing this. I have to admit, I always mean to do it, but I don't. I've heard of people just going through with their phone camera and going through their house every year and just going through every
Hmm.
room so they could have a record of everything they had that they could show the insurance company in case something happened. Maybe we should all do that today
Yeah.
in case something happens.
Yes, we
That is,
should. We definitely should. Many
that's a
of
sad
our
story.
it is, but luckily luckily everyone was saved, so that's
Oh,
a
good.
good thing.
That is a
Nobody
good thing.
died. So
Yeah, lightning, getting
thank
hit
you
by
so much.
lightning is not as rare. You'd think that's like lightning strike rare, but getting hit by lightning is not quite as rare as you think. I mean, I think there's like 350 lightning deaths a year in the US, which is, I mean,
Hmm.
there's like one shark death every 10 years. And like we're all worried about sharks. And we think lightning is this like really rare thing, but and that's just the deaths. There's a lot of other people who get hit and are fine. We had neighbors
Hmm.
behind me growing up, and they were camping and their tent got hit by lightning. They were all
Oh
okay,
my God.
but it does happen. It does happen. It's not quite as rare as you
It's
would think when you think of lightning.
exactly. I mean, we didn't think it until now when it happened to someone in the neighborhood, and now
Yeah,
everybody is talking and trying to put up lightning rods on their house just to
yeah,
be safe.
yeah. No, it's one
So
of that expression. You don't have to run faster than the bear. You just have to run faster than the people you're with.
yeah.
You don't you don't have to have the best lightning rod. You just have to have the shortest house, I guess. I'm not sure. Um,
Yeah.
all right. I have time for one
Agree.
more.
Thank you so much.
Thank you, Rupa.
Hi, can you explain what would happen with nuclear? You go
Sure.
from DC to the inverter, and I would like to know what happens when you do nuclear.
Yeah. So nuclear, to be clear, and hopefully this is clear, but if it's not, just don't admit it. There's no shame if no one knows. Nuclear replaces this guy. This guy.
Okay.
It is not at the
Oh,
house. We don't have nuclear reactors at our house because we don't want to deal with radiation. We don't want to be handling, radioactive uranium and kind of throwing it into a reactor. Now I mean, that is a possibility that we may get to a point where there's kind of small scale nuclear where it's safe enough to do that. But right now, the way nuclear works is those big power plants that have the big concrete elements that look like that, and they're super expensive to build. That's one of the downsides of them. And of course, if there's a terrorist attack or some kind of a failure at some point, they could have a Chernobyl situation. But generally, that just hasn't happened. We've had nuclear for 100 years almost, and we really haven't. We've lost, I don't know, a couple dozen people, and we're losing 20,000 people a year in deaths from coal. But those are old people who are have respiratory illness anyway, and it's hard to identify specifically that the coal power plant is the thing that killed them, even though it often is, because they died of emphysema or something because they were also smokers or whatever the case may be. So because nuclear, when it does happen, makes a lot of news. It's
mm-hmm.
like a plane crash. People estimate risk based on how often they hear about it, not by what the actual numbers are. People are really, really bad at estimating risk. I mean, just god awful. And we saw that during the pandemic when people made choices that were kind of questionable. Um, so nuclear is actually quite safe relative to our other options, which are baking the planet until we're extinct. But the idea of nuclear is that if we have photovoltaics and we have a bunch of cloudy still day, we have photovoltaics and wind, but we have a bunch of cloudy. We could have 3 weeks in a row with cloudy days and no wind. And then we eventually won't have any power, and we'll have to shut down our cities, and people lose their minds when the power goes off. They lose their minds. So we can't have that. So we need some way to smooth out the power when there's no wind and when there's no sun. And we can do a little bit of it with, like, hydro, dams and that kind of thing. Maybe a little biomass, like if we have some leftover, waste from our farms, we can burn that and get a little bit. But in general, if we're going to have to burn natural gas or oil or coal, unless we come up with a better system that's a little bit more steady. And one of those better systems, a lot of smart people think, is nuclear. But it's super expensive and they take a long time to build. And we don't have a lot of time. If any of you guys have smart kids, send them in the direction of this world. This is a really interesting world. All right.
Well, thank you very much.
You're welcome, Alma. Good night, everybody. Get licensed.
Michael, hold on
Yes.
1 second.
Yep.
We got really good news. If you got just a sec, okay?
Yeah, sure.
Oh, good.
Corinne.
Michael. Yes,
Hey, Beth.
thank you. Thanks, Tyler. Hey, Michael, it's Beth Hagberg. I'm just on here to tell you I've passed all my tests.
No.
I am now done, and I owe it to you. I want to tell you, Amber Books is wonderful, and I want everyone to know that you can do it. You got to just keep moving forward. Don't give up. I had 14 days left on my rolling clock. I am a terrible procrastinator, terrible, and life always gets in the way. So don't be like me. Keep moving forward. Do the Amber Books. I'm sorry, I'm gonna promote you, but do the Amber Books.
You know what, Beth? You don't have to
one time.
apologize for that.
Don't drag it out like me. Don't be me. Just get it all done. You can do it. If I can do it, I'm 55. If I can do it, y'all can do it. And thank you so much, Michael. I don't even know how much to say. I thank you, but just wanted you to know.
Thank you, Beth. That is
Real
wonderful
quick,
news.
Corinne too.
Okay, Corinne. All right. Well, we could do this at the end of every time.
Can you guys hear me?
We can hear you, Corinne.
Oh, okay, well, so Beth took my thunder, but that's awesome. I just wanted to let you know that I passed too on last Friday, and I've been waiting this day to say thank you.
No way. And I think,
yeah,
and of course, I've met Beth when she was coming through Virginia. And Corinne, I think we talked on the phone. Are you the one in Alaska?
Don't.
Oh, we lost her.
I'm not sure if she dropped out, but yes, she's in Alaska. That possibly is why.
I'm here.
Yeah, you in Alaska,
Can
Corinne?
you guys?
Yeah.
Yeah, I am in Alaska.
Okay,
Sorry
yeah,
about that.
yeah. Oh, I'm so excited. I hope you guys both keep coming to 40 Minutes of Competence.
Yeah, I just wanted to, like I said, the last test I took was right after one of my best friends committed suicide. So I was really really scared to take this one again.
I'm so sorry.
No, it's okay. I called you right after I failed that one, and I was like, I'm never taking that ever again. And
no.
So no, it's awesome. And so whoever out there, I have 5 kids. You can do it. It's not easy, but it's doable, and it's it was awesome. So super excited. And thank you, Mike. Some of the little tricks you put in there, I know you said you were doing some studies on don't always read just architecture. So I did that, and that totally helped to take my brain off. Yeah, I totally read pleasure, because it helps to retain more information. Absolutely. I'm a firm believer in that.
Reading is like a muscle. Yeah, for those of you guys who are what she's talking about is for those of you guys who are overwhelmed sometimes by the 4 paragraphs that start off that, an owner has hired an architect to design a mixed use building on a flat site in a warm, wet climate with schedule being the priority. And then it'll go on for 4 more paragraphs. And then at the end, it'll say which structural system is the best. And you're like, wait a minute, what? And you don't even know you don't even remember what to do. If you read every night, and preferably not architecture or studying, because that'll make you sleep like crap. And if you read every night and you even 10 minutes, 5 minutes, whatever, just so you fall asleep, you will learn to read those paragraphs. Those long 4-paragraph sections will not be as daunting, because reading is like a muscle, and it just, once you do it all the time, it's actually quite easy. So that
Yeah,
is
it was
that
great.
is fantastic.
Yeah. So and then you put another little trick in there about your logic puzzles. As stupid as
Yeah.
someone's like, why would I buy this child book? It was great. I did it with my kids, and it totally helped me on this last
No
programming
way.
exam.
Okay.
Yeah, I would
Yeah. So
promote like that for sure. You
I'm
guys
glad
did a great
you
job.
told me that, because I recommended that, not knowing if it would work, and you're the first person to tell me it worked. So I just put that in the flashcards a month or two
Yeah,
ago. So
yeah.
that is really good to know. So what she's
Yeah,
talking
so
about, for those of you guys who are curious, why don't you tell them?
yeah, I was just gonna say, who's
Actually,
ever
Corinne, I'm going to interrupt you because you're
Oh,
cutting in and
sorry.
out. So I'm going to tell them what I'm going to tell them, because they're not going to understand you. So logic puzzles, of course, are those puzzles that look like they have like grids, and they'll say like, Susie will be on the swing next to Tommy, and Tommy will not be on the swing next to someone in a blue sweater, and Jeremy is wearing a gray sweatshirt, and you have to kind of figure out who's wearing what color shirt, and who's on the swing in what order, and who's next to who, and so forth, and using those kind of logic clues. And what PA does is they have a lot of questions that are about that kind of thing, where they're saying the lobby of the building has to have access to the popcorn machine and the bathroom, and the coat check should be not far from should be adjacent to the entrance, and that kind of thing. And so you have to put it's just basically the same exact thing. It's actually quite stupid to do it in a time test, because it's not the kind of thing that you need to know quickly in real life. But it's a big part of PA, and so if you want to do logic puzzles, there's a book. I will next time we meet, I will share with all y'all the book that I sent Corinne to. I didn't get the book, honestly. I just went to Amazon and looked at a highly recommended one for adults, and then included that one. So that is wonderful, Corinne. Congratulations to you. Congratulations
Yeah,
to
so
Beth. Good.
yeah, and just in reference to your program, like there's hidden little gem, who's ever using it. The lectures are amazing, of course, but who's ever going through, there's like hidden little gems in those flashcards in the exams. Like you use all the resources and these 40 minutes of competence. It's really awesome.
Thank you so much. Thank you so much. Now you two have to now spend some time with all those loved ones you ignored over the last so many years. And give them a big hug for well, not for me, for you. Give them a big hug. All right, guys. Well, that was fun for me.
Thanks.
Good night. Get licensed.